So this next speech will be investing in inventors. Now, here's what's interesting about the symbolism of this next talk. So Janet is the program officer in charge of scientific learning at the Gordon and Betty Moore Foundation. They're leveraging cutting-edge science innovations to impact key issues at scale. More importantly, however, we talk about the law of exponentials and how that is both driving better and better lives, but also risking disenfranchisement for all of us. There's a law called Moore's Law. And in fact, the modern semiconductor was invented by Gordon Moore. And he's the one who coined the term that the processor increases exponentially every 2 years. And when we start applying it to everything from genomic sequencing to mobile penetration to everything else, we began to realize that space after space after space after space in innovation followed this Moore's Law, this law of exponentials. So with that, I'm very excited to bring you up.
Thank you very much. Thank you. Some of you may not have heard about the Moore Foundation yet. We're likely in the camp who wouldn't want to be on a reality TV show. But you may be familiar with Gordon Moore, who, along with his wife Betty 15 years ago, started the foundation in order to enable positive outcomes for future generations. So, as we heard, you might know Gordon Moore through his observation that articulated almost 50 years ago that the number of transistors incorporated in a chip had doubled every year, and it was subsequently updated to every 2 years, which meant that the processing speed was increasing at the same rate. And this observation became more or less a self-fulfilling prophecy and that drove the rapid rate of change in computing for almost 5 decades, almost 50 years. Or you might know of Gordon as one of the traitorous 8. So the group that left Shockley Semiconductor Lab in the late 50s and went on to co-found Fairchild and then Intel with his good friend and longtime colleague, Robert Noyce. But at his core, Gordon was a scientist inventor. From his very early days playing with a neighbor's chemistry set and finding out new ways to make bigger explosions, through his pursuit of a doctoral degree in chemistry at Caltech, from Fairchild to Intel, Gordon brought together this deep understanding of science with this drive to solve problems and a keen imagination that really led to innovations that changed the world. So for him, it was really about the pleasure of the problem, the fun and satisfaction of figuring something out. And figuring out something he did, his contributions to the development of microelectronics really helped produce the digital revolution that continues today. So to celebrate and honor Gordon's passion for science and his penchant for invention, the foundation recently launched a new initiative that seeks to invest in people who create the tools and technologies with high potential to accelerate progress in some of the areas that the foundation cares most about. So scientific research, environmental conservation, and patient care. So we saw the anniversary that just happened of the 50th anniversary of Moore's Law as an opportune time to do our work in stimulating this inventor ecosystem. Many of the great industrial labs that had spawned inventions for many generations were no longer in existence, such as Bell Labs, where theorists and experimentalists had worked side by side in ways that led to countless inventions and technologies and really led to the bedrock of a lot of the digital revolution as well. Most of their modern day counterparts, so a lot of the corporate labs around today, are focused on much shorter term goals. So they're looking to develop new, ready to commercialize technologies with more immediate corporate and shareholder payoffs and more immediate and near-term societal benefits. So while this change was happening, many universities are also grappling with this question about, would Thomas Edison get tenure here? As universities struggle to really balance the culture and the process around tenure and academic advancement with respect to what some may say is a false dichotomy between invention and knowledge creation. So given the importance of invention for solving large and pressing problems, for creating new possibilities, and for fueling the economy, and given the state of investments, the foundation started an initiative with two simple aims: to inspire the next generation of inventors and to elevate invention in the research and development ecosystem. So in order to do this, we are focusing our attention on this critical intersection of research and pre-commercial technology development. So the foundation has committed more than $34 million to support 50 inventors whose ideas we hope will shape the next 50 years. In total, inventors will receive over $800,000 over a span of 3 years to support their time and effort. And we're targeting earlier career inventors, so people who have been in 10 years or less into a profession. To help source ideas, we are working with major research universities, major health institutions, and select non-academic environmental research institutions. And each eligible organization can nominate up to 2 candidates for consideration. So I'm very pleased to share our first cohort that was announced just last week. So we have Deji Akawando, who's at the University of Texas at Austin, whose work with very thin 2-dimensional silicene would greatly increase the efficiency of an integrated circuit and extend Moore's law for many more decades. Perhaps we have Mona Johari, who's at UCLA, whose proposed invention would help researchers understand how fundamental biological molecules behave in natural environments. And this label-free imaging technique that she has developed could also contribute real significant breakthroughs for cancer detection, treatment, and research. We have Jinji Ni at Penn State, whose idea for a quantum light source would increase speed, scale, and security of information transmission in quantum computing. So if successful, Harry Potter would not be the only one with an invisibility cloak, as this technology would have a lot of applications for optical camouflage in all sorts of fields. Joanna Susky, who's at the University of Kansas, proposes to use our own proteins with our own natural biological mechanisms to resensitize bacteria to common antibiotics, which would help us overcome these drug-resistant superbugs that are becoming such a problem. And Shane Ardo, who's at the University of Irvine, who has already made progress on the use of sunlight to drive an ion-pumping mechanism that would boost the power and output and efficiency of electrochemical technologies. And one very clear application is a sustainable and affordable device to desalinate water for both human consumption and agriculture. So I think it's important to note that we recognize that these inventors are working within a broader ecosystem, and that we also need to help establish the conditions for productive cycles of invention and discovery. And we've heard some talk about that on this panel already. So just providing money and time and giving the license for creative use of that time to a select few is not enough. So we continue to work on ways to help these inventors and these fellows foster meaningful collaborations, support mentor configuration, and find ways to keep alive their passion and excitement. So I want to end on a note about what we aren't doing, because I think the contrast is stark and really important. We are not replicating a more academic version of Shark Tank, where there's limited time and tough love. We know that big ideas take time to flourish, that failure is a really productive and generative activity, and that invention does not proceed along a narrow and linear path. So as a private foundation, we have the opportunity and the luxury to set the conditions and exercise the patience so that inventions can emerge, grow, and thrive in all sorts of places. So thank you very much.